Hi, in this video we're going to continue with the fifth subtopic of chapter 1, transformation of functions. So this is part 2, and in this video we will learn about vertical and horizontal compression and stretch. So we learned about shift up and down, left and right, f of x plus k, shifting up and down, f of x minus k, shifting right and left. Now we want to know about what happens if a number is multiplied by f of x. For example, um, g of x is equal to b f of x, or g of x is equal to f of x. So in this case we have compression and stretch. Here stretch and compression will be in y-axis because x inputs don't change. So compression and stretch will be in y direction. In this one, b is multiplied by x, inputs are changing. So compression and stretch will be in x-axis. So when a function is multiplied by a number, g of x is equal to b f of x, so output are changing. X is not changing, y is changing. So stretch or compress is happening in y direction. If b is more than 1, then it will be stretch like this. This is original graph. This is 2 times f of x. And if b is less than 1 and greater than 0, then it will be compressed like this one, which is 0.5 f of x. And if b is less than 0, it's a combination of stretch and compression. So here we have given f of x, we will have vertical stretch or vertical compression. If a is more than 1, then stretch. If a between 1 and 0, then compressed, and a is less than 0, then it's a combination of compression, reflection, and stretch. A function p of t models the population of fruit flies in the graph. A scientist is comparing this population to another population, q, whose growth follows the same pattern, but is twice as large. Sketch the graph of this population. So q of t is twice large as this one, is 2p of t. That means we need to multiply outputs by 2. So this point is 0 and 1 for p of t. For q of t, it will be 0 and 2. This point is 3 and 3. Then for q of t, it will be 3 and 6. And this point 6 and 2. 6 and 4. 7 and 0. 7 and 0. So now here is 1 point. No, here is 1 point. 0, 0 and 2. 3 and 6. 6 and 4. 7 and 0. And if I graph it, it will look like this. Given f of x, what is g of x, which is half of f of x? It's easy, you just multiply these numbers by 1 over 2. So 1 over 2, 3 over 2. Giving f, what is g of x, 3 over 4 f of x. Again, output all will be multiplied by 3 over 4. 12 times 3 over 4. Graph in the figure is transformation of function f of x is equal to x to the third. Relate this new function g of x to f of x. So g of x in terms of f of x, what is it? And find the new formula for g of x. So f of x is equal to x to the third. X, f of x. 0 and 0. 1 and 1. 2 and 8. 3 and 27. Negative 1 and negative 1. So now here we have 0 and 0. 1, 2 and 2. This one is easy to tell. 2, 1, 0 and 0. 2 and 2. Here was 2 and 8. Here is 2 and 2. So output was multiplied by 1 over 4. So 2 is equal to 1 over 4 times 8. So g of x is equal to 1 over 4 times f of x. And because f of x is x to the third, then g of x is equal to 1 over 4x to the third. That's the equation of g of x. So when a number is multiplied to inputs, then we have stretch and compression in x-axis. So g of x is equal to f of bx. If b is less than 1 and more than 0, then we have stretch. And if b is more than 1, then we have compression. So for b more than 1, graph will be compressed by 1 over b. For b between 1 and 0, graph is stretched by 1 over b. And for b less than 0, there will be combination of compression and stretch. Suppose a scientist is comparing the population of fruit flies to a population that progresses through its lifespan twice as fast as original population. So we have another population that is fast 2 times of this one. That means the time for the new one is half of the time of this one. In other words, the new population R will progress in 1 hour, same amount that the original one does in 2 hours. So we need to multiply time inputs by 1 over 2. So if this is P of t, which is 0 and 1, 2, 3 and 3, and 6 and 2, 7 and 0. So R of t, we multiply t by 1 over 2. 0 times 1 over 2 is still 0 and 1. 1.5 and 3. 3 and 2. 3.5 and 0. So 0 and 1. 1.5 and 3. 3 and 2. 3 and 2. 3.5 and 0. So that's R of t. A function f of x is given in this table. Create a table for g of x, which is equal to f 1 over 2x. So for example, g of 2 is equal to f of 1 over 2 times 2 is equal to f of 1, which I don't have it in this table. I have f of 2, f of 4, f of 6, f of 8. So for example, f of 2 is 1 over 2 times 4. So it's equal to g of 4. We say g of x is equal to f of 1 over 2x. So g of 4 is equal to f of 1 over 2 times 4 is equal to f of 2. So what we do, we just need to multiply these by 2. F of g of 4, g of 8 is equal to f of 4. G of 6 is equal to f of g of 12 multiplied by 2 is f of 6. F of 8 is g of 16. So we can write another table. X, g of x, 4, 8, 12, 16, and f of x is 1, 3, 7, 11. On the other hand, we say that when g of x is f of bx, g of x will be stretched in x direction with a factor of 1 over b. That means x variables will be multiplied by 1 over b. 1 over b here is 1 over 1 over 2, which is 2. So all we need to do is just multiply these numbers by 2. 2 times 2, 4, 8, 12, 16. And we don't need to write all of this here. And if you look at the graph of g of x, you can see the points are getting far from the y-axis. So it is stretching by factor 2, by factor 1 over 1 over 2, which is 2. Relate the function g of x to f of x in this figure. Every time two graphs are given and asked for their relation, we need to extract some points and see what happened to the points. So here we have f of x and g of x. 0 and 0, 0 and 0. 4 and 4. This one is difficult to say, this point. So let's go to the next one. 6 and 4. 2 and 4. So f of 6 is equal to 4. G of 2 is also equal to 4. So f of 6 is equal to g of 2. So 6 is equal to 3 times 2, right? G of x is equal to f of 3x. So the graph is compressed by a factor of 1 over 3. Given table f of x, x and f of x, create a table for g of x, which is equal to 2 times f of 3x plus 1. So let's find f of 3x first. We said that when we have f of x and we want to find f of bx, so this is just f of x is stretched with a factor of 1 over b. That means we just need to multiply inputs to 1 over b without changing outputs. So here b is 3, 1 over b is 1 over 3, so I just need to multiply these numbers by 1 over 3. So here the table x f of 3x, 6 divided by 3 2, 12 divided by 3 4, 18 divided by 3 6, 24 divided by 3 8, 10 14 15 17. Now 2f of x, that means we multiply outputs by 2, so x is same, just 2 of f 3x, 2 times 10 20, 28 30 34, plus 1, another table, x 2 4 6 8, and 2f of 3x plus 1 is 21 29 31 35. Use the graph to sketch k of x is equal to f 1 over 2x plus 1 minus 3. So first let's factor 1 over 2 inside the parentheses. So k of x is equal to f of 1 over 2 x plus 2 minus 3. So x plus 2 was multiplied by 1 over 2. In f bx, we said when b is less than 1, it will be stretched, and the stretch is the factor of stretch is 1 over b. So 1 over 1 over 2 is 2, so I need to multiply this by 2, and this is not changing. Then plus 2, so fx minus k, I need to shift 2 units toward left, 1 2, negative 6, then minus 3, 3 units shift toward down, you shift it to 3 units toward down, 1 2 3. This is the final graph.